Welcome to Assembly News Now. This is multimedia editor Jennifer Pierce, and here's what's happening with product assembly on September 2nd. Mercedes marks a manufacturing milestone, and a new technology prints wiring. Next, a new process joins plastic to metal. And for our top story, Ford invents a new process to assemble a mass-market EV. And finally, BMW helps Germany gear up for the Winter Olympics. These Assembly News Now stories after a brief message from our sponsor, Motion Index Drives, a leading manufacturer of rotary, linear, and multi-axis precision indexing devices. Motion Index Drives. Rotary index tables, precision link conveyors, weld positioning systems, tooled tray shuttles, robot transfer units, and much more through your customized specifications. Learn more at www.motionindexdrives.com. For our first story, Mercedes marked a manufacturing milestone this year by producing its 5 millionth Sprinter van. The van was assembled at the company's factory in Charleston, South Carolina, and delivered to FedEx, a longtime customer. Mercedes introduced the Sprinter in 1995, and it quickly became a top seller. Since then, the van has undergone 3 redesigns, including a fully electric model. The Charleston factory has been expanded twice since it opened in 2006. In addition to Charleston, Mercedes assembles vans at 2 factories in Germany. And for our next story, British company Q5D is changing how wire harnesses are made. Instead of cutting and stripping individual wires and assembling them into a harness, Q5D has introduced a large-scale gantry robot that prints wires directly onto a surface, secures them in place, and terminates them. The machine can deposit wire at a rate of 1 meter per second. It has a build volume of 8.2 feet by 4.9 feet, which is large enough to accommodate a vehicle headliner. Printing wire onto a part saves labor costs and eliminates the need for clips or wraps. The robot is programmed directly from a CAD model of the product and the wire harness. And now for our next story. Kist and Escherich have developed a new process called HiJoin that can assemble plastic to metal without adhesives or fasteners. The process can create both spot joints and watertight seams. It can also be used on many types of plastic and metal. Prior to assembly, the surface of the metal is roughened with a laser. Then the metal is selectively heated through electromagnetic induction. During heating, the plastic part is pressed against the metal part. The plastic melts at the contact area and flows into microscopic crevices in the metal. After cooling, the plastic solidifies and becomes mechanically interlocked with the metal. And now for today's top story. Ford Motor Company plans to build a new mid-sized electric pickup at its assembly plant in Louisville, Kentucky. The company says the $30,000 vehicle represents a Model T moment that will make EVs available to more people, just like the Model T helped to popularize automobiles when it was launched in 1908. Here to tell us more is Chief Editor John Sprovieri.
Ford is spending $5 billion to retool the 70-year-old factory to mass-produce vehicles based on its universal EV platform. The plant currently assembles the Ford Escape and Lincoln Corsair on traditional lines that move vehicles from station to station. Ford will be able to make the new pickup much faster by using an assembly tree process instead. The tree will consist of 3 parallel lines where operators assemble the front structure, rear structure, battery pack, and interior. Seats and other interior components will be attached on top of a structural battery pack located in the floor of the vehicle. Near the end of the line, the front and rear will be combined with the battery pack to complete the vehicle. Large, single-piece aluminum castings replace dozens of smaller parts, enabling the front and rear of the vehicle to be assembled separately. In fact, the new design reduces parts by 20% compared with a typical vehicle. It will require 40% fewer workstations and 15% less assembly time. Wiring harnesses will be 4,000 feet shorter and 10 kilograms lighter than the ones used in Ford's first-generation EVs. Parts will travel down the assembly tree in kits that contain all the fasteners, scanners, and tools required for the job in the correct orientation for use. This will dramatically improve ergonomics by reducing twisting, reaching, and bending.
Thanks, John. And finally, the Winter Olympics are just 5 months away, and German teams will once again be the favorites in bobsledding. One reason for the country's dominance in the sport might be the help it gets from automaker BMW. Engineers at BMW are using additive manufacturing to develop new shoes to help bobsledders maximize acceleration at the start of each run. Conventional shoes have spikes that are permanently attached to the front of the sole. The spikes cannot be adjusted, and when they wear out, the shoes are thrown away. BMW engineers designed a shoe with replaceable and customizable spikes that can be positioned anywhere on the sole to suit the needs of the bobsledder. Additive manufacturing lets engineers create new spikes without spending a fortune on molds and tooling. That's all for this edition of Assembly News Now. For all the latest news on assembly technology, visit assemblymag.com. And be sure to follow us on social media. Thanks for watching, and tune in next month for another installment of Assembly News Now.